I want you to talk to me about Fukushima.
Okay.
What happened there? So rather than me just give a rough intro, my understanding, just what happened at Fukushima.
So what basically happened? It was my understanding that the Japanese regulatory group operated somewhat differently than what our Nuclear Regulatory Commission does in the United States. So the way we operate it's kind of like having a police officer. That's what you call them, right?
Yeah.
England, police officer. A police officer driving around in the car with you all the time.
Okay.
Right? So we have one on site all the time. When the regulator gives you recommendations, you go do those things. Well, the Japanese regulatory agency does not appear to have been maybe as independent. They had given some recommendations of some things that needed to happen to protect from the eventuality of earthquakes and tsunamis. Some of the plants in that area did do what they were supposed to do, the recommendations. They had no problems. The ones that did, when the earthquake happened, the off-site power went down. Okay, the reactors shut down like they were supposed to. Their diesels started to provide backup power because when a reactor shuts down, the high-level power generation stops, but you have what we call decay heat from fission product decay, which continues to generate some level of heat less than normal power heat. But you have to remove that by circulating water. They had to have these emergency diesels to power the pumps to circulate the water to remove that heat. Everything worked exactly like it was supposed to. The diesels were located entirely too low in relation to what they should have been. So when the tsunami came, it swamped the diesels and the diesels shut down. Now, the earthquake had already shut down the power offsite. The tsunami shut down that power. Nothing was circulating water. So 3 important things with the reactor, right? You got to control it, you got to contain it, you got to cool it.
And in a scenario where you want to shut it down, if you successfully shut it down, have you neutralized all the threat, the majority of the threat?
You have neutralized the criticality of the reactor, so it no longer has a self-sustaining criticality. So it's no longer splitting and giving you the 3 extra neutrons that go on to make more reactions. But you still have the fission products that it takes them some amount of time to decay, and they release heat while they're decaying, right?
Okay.
So you have to cool it during that interim.
Okay. And the risk, just so we understand the risk, when there is a risk to a nuclear plant, what is the risk that they're trying to avoid happening?
So meltdown of the fuel would be, right? That's why you have to control, contain, and cool, right? So you insert the control rods that are made of something like cadmium, hafnium, whatever the case may be, and that absorbs the neutrons and shuts down the nuclear chain reaction.
Is it like a casing?
If you can just imagine like a long pencil, and it gets inserted down into the reactor. So it goes down into the reactor where all the neutrons are interacting with the fuel, and it absorbs, it soaks up all the neutrons.
Okay.
So the criticality stops.
And how long does that take?
Instantaneously.
Oh, instantaneously.
I mean, it's some amount of seconds or maybe a minute, but I mean, it's practically for all intents and purposes.
And the risk is if that doesn't happen and the neutrons start going crazy.
So they fail, the rods will fail by going to the bottom.
Okay.
Right. So even if the worst case happened and one of them were ejected or something, the rest of them would shut it down. Right. I mean, it's a fail-safe method. Right. What happens is when you can't remove that residual decay heat from the fission products, that's the problem. So as we have gotten into generation 3 and 4 reactor plants, they now have much better systems than the one at Fukushima. They have like gravity-fed cooling. So they don't need pumps and diesels in order to supply that power. It would just gravity feed down and cool them.
And is the risk here that when a plant goes into meltdown, that too much steam is created, creates too much pressure, and that's what causes an explosion?
Well, not explosion. Remember, we talked about that.
Well,
it could cause a violent release, right?
Yeah, but when I say explosion, not like a nuclear explosion, I just mean like there's too much steam and it causes some kind of
Yes.
pressure and
Yes,
the pressure
expansion.
Yeah.
Which could be released, right? I like to be careful because
Yeah.
the word explosion, that's a touchy word. It usually is associated with bombs, right?
So I'm trying to remember it from watching Chernobyl, whereby my understanding is that there was so much pressure from all the steam, and that caused.
Yes.
The only one I can think of is explosion because
and understand the problem at Chernobyl was they had no pressure containment building.
Yes.
Right, and that is a huge. That's the only example of that in the world. Basically, what Chernobyl was, it was the.
Shall we come back to Chernobyl?
Yeah, we can come back.
Because I want to discuss that separately. But that's the issue is the pressure, and if there is like a pressure release, that would release the that would shoot the nuclear radiation outwards.
Yes, radiation and contamination.
Yes. Okay.
You understand the difference between radiation and contamination?
So for me, radiation is the neutrons.
It's the electromagnetic waves.
And the contamination is the nuclear waste getting into the soil and atmosphere?
Finely divided particles.
There we go.
Yes, right. So the contamination is just finely divided particles. Like if you were to take a file and file a piece of metal, and then the radiation is the waves coming off of that.
Okay, I understand.
Right. And then what you're really worried about is you've got alphas, betas, and gammas.
Yes.
Right? And they react with your body differently. Right? The alphas can be the most damaging if you get them internal, but they pose no health risk if they're external because they can't get through the dead layer of skin on your body.
Okay, I understand.
Where your betas don't do quite as much damage, but they can't make it through your clothes. The gammas are really the ones you're concerned with.
Right. Okay. So back to Fukushima, there was no ability for the diesel generators to run, so therefore they couldn't go through the shutdown process.
Well, they were shut down at this point. They just could not continue to circulate cooling water.
Okay. So what happened after that?
Okay. So then you started getting the pressure build up, right? And then as the pressure built up, you started having the releases that you were talking about with damage to the fuel, subsequent releases due to the pressure buildup. Right?
Okay.
Then they had to, of course, vent some of that. They had to release some of that water, right? Because the pressure continues to build up, right? So, they were trying to pick strategic times to do it when they could. I mean, but it was, it was a mess, right? So it took some time.
And was there a meltdown at Fukushima?
Yes.
There was?
Yes.
Okay. How serious a situation was that?
I think anytime you have a meltdown, it's a serious situation. I mean, 3 Mile Island, Chernobyl, and Fukushima, right? All three of them were serious situations. Now, Chernobyl being by far the worst, then Fukushima, then 3 Mile Island in that order.
Okay. And in terms of Fukushima, do we know the collateral damage?
Sure.
So is there a quarantine zone?
So they call it an exclusion zone.
Yeah.
So just perspective, because it's important, right?
Yeah.
So most of your radionuclides decay relatively rapidly. Mm-hmm. For instance, you're worried about radioiodine. That's the one that will cause thyroid cancer. It has about an 8-day half-life. Something has to go through 5 half-lives in order to no longer really be a concern. Okay, so after about 40 days, that was all decayed away and was no longer a concern. Then you've got a multitude of other things, right, that all decayed away. Cesium-137 is a gamma emitter. That one has a 30-year half-life, right? So you're talking much, much longer, right? Plutonium has an extremely long half-life, okay? So at this point, those are the things that are left. So for perspective, current radiation levels, now this is a general radiation level in that exclusion area. I understand there'll be people that are listening that can probably find something on Google that shows one spot somewhere, 1 square inch that's different, right? But the general level is about 200 millirem per year above background. And remember, background can range from 300 to 26,000. So what I'm telling you is the amount that is still there would be much like you getting on a scale and saying, I weigh 160 pounds and eating a peanut and thinking you're going to see the difference. Right? It's not.
And at Fukushima, I'm trying to go by memory, but was it not the case they had to send some workers into the plant, into a dangerous environment?
Oh, absolutely. Just much like they did at Chernobyl.
Yeah.
Right? I mean, there's things that, and that's a great question because what really came out of Fukushima was less There was a little bit about design in that, how do you get your backup power and what are the constraints on your backup power, and is your backup power really reliable, which was a great thing. But what really came out of Fukushima during the hot washes where they debriefed and really studied the lessons learned was response, preparation, training, people, right protective clothing, understanding. Those lessons that came out of Fukushima, that was what was really learned, right? So in the future, they will have a much better plan, right? So we were able to help them a lot with that when they sent us in because we very stringently train on those things in the United States.
Oh, so you went out there?
Yes.
Okay.
Yes. So I was working down in Georgia at the time. And then when that happened, they flew me to the Ronald Reagan Strike Group, which was the aircraft carrier strike group that was off the coast that had actually went through the radioactive plume and had some contamination deposited on the ship and the other ships. They flew me out, and I helped with the recovery efforts from the carrier strike group side, while other people from our regulatory agency worked with the Japanese government. So I headed up the efforts in the strike group, and it was basically making sure that when we went out to fly missions, because we were flying routine relief missions, I think it was somewhere in the neighborhood of 250,000 tons of relief, of food, water, that we took to them. I would decontaminate the helicopters when they came back, decontaminate the people, made sure that anything they picked up they didn't bring into the people space, decontaminate the flight deck of the aircraft carrier, right? So we worked on a lot of things like that.
Do we know what the resulting number of deaths, casualties, cancers from
Zero.
From Fukushima?
Nothing. So no deaths from Fukushima. The World Health Organization, the last release that they had, said that there would be no observable increase in cancers from Fukushima. Now, what is meant by observable? Right? It's one of those terms that I think we have to understand. So 25 to 30% of any population dies of cancer anywhere. Just pick your group. Okay. What that means is that there are going to be people that were there that are going to die of cancer, but it's going to fall within the statistics of the 25 to 30% that would normally die of cancer. There will be no observable increases.
And even the workers who went into that dangerous environment?
Yes.
Yeah, interesting.
Okay. The only example we have, of course, the same with 3 Mile Island, it was no deaths, no cancers, right? Of course, you got, when they're looking at the cancers, they look at like leukemia. So that manifests itself relatively quickly, say within 10 to 20 years. So we're definitely past that on most things like Chernobyl and 3 Mile Island. Your solid cancers take longer to manifest, right? So they have to do statistical analysis, right, for those things. But yes, so Chernobyl, 46 people died at Chernobyl, right? And the worst case, most conservative estimates are that 4,000 total could die from cancer. That's the worst case. Statistically, it will probably be much, much less than that. The real sad story of Chernobyl is, for instance, it's estimated 200,000 women aborted their children for fear of genetic effects. And there has never been an observed genetic effect from radiation exposure ever, not even in the 70,000 people they have tracked following the atomic bombs of Hiroshima and Nagasaki. Zero genetic effects.
The interesting thing about these numbers is that I wonder how many people have died mining coal.
Okay, well, for instance, how many people died of shark bites last year? 11 to 15, right? People are terrified of sharks.
I am.
Okay, 40 people died from dog bites. You probably love dogs.
I think I would have thought that number would even be higher.
Right, okay.
Yeah.
87,000 people were accidentally poisoned in their homes last year.
Yeah.
Right? And the worst is vehicular accidents. Just in the United States alone, 45 to 50,000 people die a year in vehicle accidents. 6 to 7 million from air pollution, from fossil fuels and other industrial pollutants. 7 million. Improper diets and lack of exercise, 11 million a year. And we're worried about the 46 at Chernobyl, which was a horrible design, horribly engineered. Yeah, it was basically, they had it built in a tent.
we will come back to Chernobyl. Just back on Fukushima.
Yeah.
Was the location a poor choice, being that close to the ocean?
I don't think the location was a poor choice. No? The location, it was not engineered properly for the location.
Okay.
That makes more sense, right?
Yeah. Do you think, will Fukushima ever be an operational plant again in the future?
I do not know enough to answer that.
No, okay.
Yeah, I'm not sure what their plans are with that and what they're going to do. I know the other plants that had taken the right precautions are still operational, and I do believe that they have plans to continue to operate those.
Does it not make sense that all plants globally operate by the same standards? And is there an attempt to do that with the International Atomic Agency?
It's my understanding that that's their intent, is for that to happen. And it's the more knowledge sharing that we have and the more training, cross-training that we have, the more interaction between agencies we have, certainly the better that gets. We saw that following Katrina, right, in the United States. Our agencies did not interact well together, and a lot of things happened that could have been avoided because of that, right? So yes, absolutely. Standardization is key, yes.
Okay, let's talk about Chernobyl.
Okay.
You said you've not watched the series. Nope. What is your fear?
So when I'm watching shows like that, I get frustrated at some of the, which I'm not judging that one because I haven't seen it. I can always speak to things that I have seen and read. For instance, the initial reports, when you go read the initial reports that came out of Chernobyl, they were estimating hundreds of thousands of people were going to die. There was a report of a mass grave that they had bulldozed 15,000 people into. It's just insane, the propaganda, the hysteria, right? So I get frustrated when I read and watch things that aren't based on reality, right? Right.
So, I mean, my only recent education of what happened at Chernobyl is from that show. Right. So, but based on that show being, my assumption is at least partially accurate.
Sure it is.
Some of the main issues were not proper operations, processes,
yes,
poor management, and then following the explosion was the desire by politicians to interfere with what's happening. That seemed like the primary issues.
We all have that problem in our countries, right?
Yeah, we do.
Right.
We do. But this seems like a problem of history.
Yes.
It's not the kind of issues we hope we wouldn't have now anyway.
Right. So I think that we as a people do a lot. We're very poor at risk assessment, right? Maybe this would be a good time to talk for a minute about how the fear and superstition happens, okay? So back when we first developed nuclear power and atomic energy, there was a lot of secrecy, big government secrecy, right? It was also associated with the military, industrial complex. A lot of people's not so favorite thing, especially our libertarian friends, right? Okay. So that secrecy really turned a lot of people off. Then you had all the weapons testing, which scattered a good bit of radioactivity around the globe by all countries involved over time. That really turned a lot of people off. You had a whole anti-war movement back in that time period, late 40s, 50s, 60s, that they knew there was nothing they could do about the nuclear weapons, because even if we were to give them up, as soon as we went to war, we would all make them again. So there's a thing called the psychology of distancing. What happens is, let's say one of two spouses goes to work and is having a hard time with their boss. So they go home and they yell at the other spouse. The other spouse says, okay, so they go and yell at the kids. The kids can't do anything about that, so they go kick the dog. Okay. They couldn't do anything about the weapons, so they turned their angst to nuclear power. So that started the anti-nuclear movement. People fear that which they don't understand. And when something is not clearly understood, people think more of consequence than they do probability. We're horrible at risk assessment. Absolutely terrible at it as people. That's why people are more afraid to fly than they are to drive, even though the odds per mile of them dying in a vehicle are much, much greater.
Yeah, you don't want to fly with me.
There you go. Right? Because they don't feel like they're in control.
Yes.
Okay.
I think, it is fear of consequence.
Absolutely. So they think more about, so what it is, they start substituting the how do I feel about it question with the what do I think about it question.
Yep.
And it all becomes about feel, right? It doesn't become about facts. The media will always report on things. If it bleeds, it leads. Right? So it's much like FTX and Bitcoin. Right? We've got to work some Bitcoin in. Right? Okay. So Bitcoin has gotten lumped into what happened with Luna and FTX because Bitcoin equals cryptocurrency equals Luna and FTX bad, so it's all the same. That's what we've done with nuclear power over the decades, right? And the media feeds that because they're not nuanced and educated enough to have the nuanced conversation on air. And a bit on air is 7, 15, 30 seconds. So they just shoot out this little headline of information that totally lacks understanding and nuance and lumps everything together. So that's what's happened with nuclear power. We recall information through an availability heuristic. So when you have heard something over and over, whether it's true or not is irrelevant. If your mind recalls it quickly, you'll believe it's true. Then when you see several different media outlets doing this, you have what they call an availability cascade. Then the more they report on it, the more afraid people get, the more they watch, so the more they report on it, and you got a positive feedback loop. So that's what happens in regards to these things, right? They lack nuance and understanding, right? People confuse plausible with probable. They think just because something is plausible that it's probable. They have nothing to do with each other, right? You can develop a coherent story in your mind that's plausible, and the odds of it occurring can be 1 in a billion, 1 in billions, but it could be plausible in your mind, right? Right. So that's what's happened with a lot of this that makes people fearful and superstitious. And then it becomes almost like a religion. Right? Have you ever noticed how apocalyptic we are, human beings in general?
Yeah.
Every major religion out there has an apocalyptic ending, right? We're apocalyptic. We're drawn to that, right? So things like Chernobyl feed that.
Yeah.
Even though the numbers of the worst case thing that could possibly happen, the worst engineering, the worst casualty control, the worst design, everything, 46 unfortunate individuals lost their lives.
Yep.
Okay. 10.9 million a day from poor diet and exercise.
10.9 million a day?
Oh, a year.
Yeah.
A year.
Yeah.
From poor diet and exercise.
Yeah.
Right?
Well, I just think of mining disasters.
Yes.
You hear about a mining pit caving in and 100, 150, 50, all these different numbers.
You ever heard of Bhopal, India?
No, but tell me.
So Bhopal, India is the worst industrial accident to have ever occurred. There was a Union Carbide plant. They were making methyl isocyanate, which is basically used in adhesives and plastics, pesticides. Someone left a valve open and released it. It killed 15 to 20,000 people and gave 500,000 respiratory distress.
Wow. Okay.
Wow.
Yeah.
And that's a plant just like a nuclear plant.
Yeah.
Right? We didn't go shut down all the methyl isocyanate plants. We still build them. They're in the United States. We learn. We move forward. We took more precautions. There was a dam that broke in China, killed 26,000 people, and another 171,000 died of malaria and starvation following the dam break. That's way worse than Chernobyl.